Welcome to Google Developers Live here on the Chrome channel. And today we have a really exciting episode of a new series, Ask the Author, with where new book authors explain about their book and the new exciting technologies they're talking about. So with me I have, talking about the definitive guide to HTML5 WebSocket, I have the three authors that wrote it, and starting with the first one, Vanessa Wang, welcome.
Thanks, Peter. I'm Vanessa Wang. I'm one of the authors of the book. I'm currently manager of technical publications at Kazing, which is a startup in Mountain View, where I write documentation for our WebSocket platform.
Great. And Peter Moskovits?
Hi, I am Peter, and I head up real-time solutions at Kazing, and I work very closely with the developer community out there.
Great. And Frank Salim?
I'm Frank. I am a software engineer at Google, and I used to work at Kazing.
Yeah, full disclosure, I also used to work at Kazing, so it feels like a little bit of a reunion here. So tell us a little bit about the book in general, and like what can we expect to find in the book, Vanessa?
So we start off the book with a little history of why WebSocket, and then we go into the API and protocol. So the standard is comprised of the WebSocket protocol, the communication protocol, and the API that interfaces with it. And then we deep dive into three hands-on examples of how to use WebSocket with higher level protocols such as XMPP, which is a chat application, and STOMP for PubSub, and VNC, which is a binary protocol. We also go into some of the security and deployment considerations at the end.
Great. Yeah, and I saw a great appendix as well on how to debug it, and we'll get back to that as well. So why did you think, when you started writing the book, Peter, what prompted you to do that? What was the, why was it a good time to come out with the book?
It was a long time until WebSocket became a ratified standard, and in December 2011 it was accepted. RFC is out there, and we felt that there is a need to share the experience that we've gathered in at Kazing. We started it over 4.5 years ago there, and we wanted to share so that basically people can get started and use it.
Great. All right, so maybe just for everyone that's watching and has questions about WebSocket, by the way, we have in the on the YouTube channel, we have a link to the questions, the moderator. So we have a moderator where you can vote and ask questions. Definitely use that. We're going to get back to those questions at the end of this program. And for now, we'll talk a little bit more about this. So what are some of the core concept before we dive too deep into it? What is WebSocket? Maybe for those of you that don't know.
So maybe I'll take that and then others can chime in. WebSocket allows you to have a full duplex, always-on connection between your browser and a WebSocket server, and it allows you to build applications that we've been trying to build for a long time. When we first moved to the web, initially it was around static, and then later on dynamic documents, getting these documents into the browser, and the browser was used in a pretty dumb way. And then as browsers evolved and the JavaScript engines became more powerful, clearly we could start moving some of the business logic that was running on the application servers and on the middlewares over to the browser. And around the same time, it was clear that we needed a better way to connect these applications that are running in the browser. And WebSocket addresses that. And not only does it have this very low latency communication, it's also designed to be web friendly. I mean, we can talk about this a little bit later on, but the whole idea that with HTML5, basically applications running natively in the browser without the need of extra plugins and extra extensions, it can become very powerful.
Right. For example, Flash has a socket, right? I think there was a question about that on the moderator. We'll get back to later. But
exactly, Flash has socket, Java has socket, and doing this whole socket connection in a standards-based way, where everybody does it the same way, and you can assume that it works across the board, and how well it works. Again, I guess we can talk about that later on. Is what makes it really nice and powerful.
Very good. Yeah, it's very exciting to see a complete book devoted to WebSocket. One of the things I liked about your book was the demo VM that you shipped. So most books, of course, have a GitHub repository. I believe you have that too. But to get started with WebSocket, of course, it requires a client, but also a server. And that's maybe different from other parts of HTML5, which is usually sort of like a client-side API, and you can use that. But for WebSocket, you do need that other endpoint. So tell us a little bit, or maybe you can demo it.
Sure. So maybe I can
right.
give you a quick idea here on my machine.
Great.
So the first thing that you mentioned was GitHub. If you go to GitHub and you search for WebSocket book, the source code
right.
is easily accessible, grouped by chapters here. In addition to this, you can also download a VM along with the source code from the publisher's website. So all you need to do is, again, search for WebSocket on the Apress site, and here you see the book. And on the bottom of this page, there is a source code and downloads, and this is where you can download the VM.
Great.
The VM is very straightforward, relatively small, starts up in no time. It's a VirtualBox VM and has Ubuntu on it.
Okay, and you just need the VirtualBox player.
Yes, that's all you need.
Right. Okay. Right.
You get VirtualBox and you can open up the VM.
Perfect. Okay. Cool. So, can you give a quick demo on how you would start it and
sure.
And use
so,
it?
Actually, I've already started up the VM.
Sure.
When you take a look at it here, you see the chapters out there on the desktop. There is a README file that comes with every chapter. So when you open it up, you see the README file that gives you the steps that is related to the actual chapter. All the source code is obviously included here as well. And in addition, we also have a video that is in every folder here. So this is a set of screencasts that walk you through the steps of doing these hands-on kind of exercises in this environment step by step. So it's really easy and really straightforward. Maybe I can quickly start one, and just basically this is the experience.
Mm-hmm. One of the purposes of the VM was really just to give different access points to the code, so you can walk through the code in GitHub. But also, if you don't really learn that way, you can just start it up on the VM and then walk backwards, following the examples in the book, and then figure out how it was built just by looking at the VM.
Yeah, I like that, because I mean that's often the problem, right? Sometimes you don't have time to see the whole thing. You can see the finished solution and then quickly get to
without having to bootstrap a lot of the environment.
Right.
Like each of these chapters might have a different server that comes with it. It's pre-configured in the VM. There's a chat server and a messaging server, and they're all in there.
These are like pre-seeded servers, right?
Yeah.
Okay. Awesome. Great. So we talked a little bit about what WebSocket is, but what are some of the practical applications today that you can accomplish by using the standard? Right.
So maybe I can show a couple, and then
Great.
we can take the discussion from there.
Yeah.
The first one is going to be a demo that we like to call the portfolio demo. One of the typical use cases for WebSocket is that you have a large amount of data available on the server, and you want to get this data to a number of clients, to typically a large number of clients, very quickly and in basically at real time. And this is one of the of the demos that showcases this. So what you see here is imaginary data, so it's not real market data, obviously.
Sorry, that we are
sell my stock that we are showing here. And depending on your network connection, I saw a bit of a stop there. You see the data come in. So one of the things that you can do is you can open a new browser window, and this demo is available on the public internet. So you can go to the URL that you see here, and you can run this demo yourself. You can execute. Basically, the data is coming from the server to the client. This is something that's not very easy to do when you're using HTTP, but it also shows the bidirectional nature of WebSocket, where not only do you see the data coming in, but you can also initiate trading.
So to buy a stock, you would send a message,
exactly,
and you would receive
when you buy
messages, right?
Yeah,
right,
exactly.
Yeah, I think that demo really highlights a lot of the cool parts about WebSocket as opposed to, let's say, what are typically called Comet implementations that are basically HTTP requests that are either polling or long polling, right? So what's the typical reduction of overhead in something like this that you would find?
So when you speak HTTP, along with the request and the response, there is a number of headers that are sent over, and these headers can range from 800 to 1500, sometimes even 2000 bytes. And when it comes to sending and receiving small amounts of data at a high frequency, then it all adds up very, very quickly. With WebSocket, the header and the overhead is in the number of bytes, 4, 6, 8 bytes. So when you're sending over a character or a small number or something really small, then it can be 100 or even 1,000-fold the speed improvement that you can achieve, which is impressive, especially when you have hundreds of thousands or millions of users out there.
Yeah, that's great. Cool. So in the book, so you said here JMS. So in the book, I noticed you talk a lot about, of course, there's the core WebSocket. That is the API and the protocol. But then you also talked about XMPP, you mentioned Stomp or remote frame buffers, the VNC protocol, I guess, if you will. Tell us a little bit about what the architecture for something like that would look like.
Yeah, so WebSocket really lends itself to a layered architecture, where if you treat it like a transport level protocol, like an analog to TCP, and speak application level protocols on top of that, that's an approach that we think works really nicely, and we describe at length in the book.
Right. Is that also part of the standard?
Yeah, so the standard contains support for higher level protocols. They're called sub-protocols, which maybe isn't the most straightforward term. But yes, with the standard you can create a connection that negotiates a protocol with a named protocol, and the contents of the WebSocket conversation will adhere to that other protocol.
Right. But have any browser shipped with any sub-protocol support today, or not yet?
Well, support for the sub-protocol features is baked in. Right. And it's more up to the application to bring along sub-protocol support as part of a JavaScript library.
Okay, I see. Right.
So here on my screen, I quickly brought up a diagram that kind of talks to this point, where you have your clients on the left-hand side, you have the WebSocket connection going all the way to your WebSocket server, and then you have a TCP connection all the way to the back end. And typically the TCP connection that you have on the back end, it can be really any rich business protocol, but when you have in a traditional web application, you basically break that bidirectional connection as you go out to your web clients, and this is what WebSocket is addressing. And not only do you have the full duplex connectivity between your clients and your WebSocket server that can then be basically connected all the way to the back ends, but you can, very much like on TCP, you can build these higher level, richer protocols. So interestingly, from a server's perspective, you don't necessarily or don't even know whether the client that is connecting over TCP or over WebSocket, as long as it speaks that specific protocol. Right. XMPP is a good example, and we have an example for that in the book.
Yeah, cool, great. Well, before we dive into any further examples, what's the level of support like right now? Like what browsers, especially the mobile browsers, what's the support landscape, and where can I find out?
So maybe here I can show caniuse.com.
Great.
So if you filter this for WebSocket, you see where we stand today. It shows that the currently used browsers, 58-59% of them do support WebSocket natively, which is good on one hand. It's pretty bad if you consider that you may be losing 30-32% of your users who are going against a WebSocket-enabled application. Right. So that is a challenge. That is something that we see out there that people are kind of struggling with. So it's very important that you make sure that whatever server you're using, you have the right level of emulation or fallback to support all those browsers that do not have native support.
Yeah, like polyfill libraries and so on. Right. So
I think it's worth mentioning that the latest version of all the major desktop browsers supports WebSocket.
Yeah, that's a big deal, right?
Yeah.
So IE10 joined.
Future looks good.
Yeah. Right. Yeah, that's actually pretty good. The percentage there, because you're always going to have sort of the old IE that's not going to support it. I mean, you can't. I mean, it's more like what's happening on the, in the future browsers that's important, right?
I was thinking I have another demo that maybe we can show.
Yeah, perfect. Yeah.
So we saw the use case where we have a lot of data coming in from the server, and we want to share this with a number of clients. Another interesting use case that was really hard to achieve before the world of WebSocket is this peer-to-peer or pseudo peer-to-peer kind of connection. So one of the first kind of quick demos that I built when I started looking into WebSocket is a demo called the bouncy ball demo. And I'm going to bring up a simulator here and open the same page here in the simulator, and just to play safe, I'll reload this page. And what we see here is that the two are side by side, and maybe I can resize this Chrome window here a little bit so they can be truly side by side. And what we can do is with a simple tap gesture on the phone, we can connect these two screens. You see that there are basically two HTML pages with canvases rendered in there. And when I tap and demo not behaving, let's try it again.
Let's try it again. They would basically share this. Yeah. Okay.
Here we go. And when we actually, we may need to. Here we go. So what happens is the two screens are connected. So basically, they negotiate who is on the left and who is on the right. And when the ball comes to a shared wall, then a message is sent from one browser to the other through the WebSocket server, indicating that the ball is coming at this position. This is the speed, this is the direction where it's heading. You take over the rendering now, and then the other browser can render. It's important to mention that this is not a true peer-to-peer connection. It goes through the server, but you can achieve the kind of the...
Yeah, there have actually been a few moderator questions that we'll get to later, talking about like the connection with WebRTC. So let's come back to that. So that's just basically a canvas implementation on both clients, right? Okay, right.
Actually, I happen to have another one, if this is a good time. This one is a video that shows a WebGL car on a screen. This is a pretty cool car by itself. And in the bottom right corner, what you see is my phone. And as I am tilting the phone, I'm driving the car. And the way it happens is I have a browser run on my phone as well, detect the tilt status. And as quickly as I can, I'm sending messages to the connected WebSocket server. And since they share the server, it can be bounced back using this reflector model. And it can be done very quickly and very easily if you're using concepts like PubSub on top of WebSocket.
Right. The high-speed messaging, basically.
Yeah, exactly.
Oh, that's excellent. Yeah, I like that demo a lot. That's really cool. So, so what do you see? What other sort of applications are being built today with WebSocket? What's happening in that world?
Yeah. So, in addition to some of the examples Peter outlined, which is large amounts of small bits of data being sent out to multiple clients at the same time. We're also seeing a lot of gaming games being developed, browser-based games. They're using WebSocket, especially like MMO type games. I think Mozilla did a Browser Quest game a little while ago, so did Rob Hawks with Twitter, rocks.com. And, sorry, it was called Rockets, I think.
Oh, yeah, Rockets.
So, but we also see some other ways that people might be using this for like crowdsourcing type apps, like Waze, something like a GPS or traffic conditions, where a lot of people need to send lots of data over the web in real time.
Yeah, Waze is really cool. One of their recent features is that
the GPS
app. Yeah, you enter an address, you navigate somewhere, and then you can share your trip with somebody else. So in their browser, they can basically follow how you're getting to a given point. So you go and pick up somebody, and they can see where you're stuck in traffic and how it goes. Now, I don't believe they use WebSocket, and I think their refresh rate is somewhere in the 30-second or maybe 1 minute rate. But if they would be using WebSocket, then they would be able to see true real-time data.
Right. Well, that's cool. That's cool. So, I mean, that's great. Where do you see? Because IE only added the support when, like last year, right? When IE 10 came out. So, fast forward 2 to 3 years, even 5 years. Where do you see, like with ubiquitous fast connections and everything on mobile? Where do you, or what sort of applications do you envision for WebSocket?
We already see a lot of interest in machine-to-machine communication, Internet of Things. There's an interesting company that I talked to not too long ago where they have the ability to produce these little devices in a very cheap and very efficient manner, where that they can basically put out and monitor things like parking spots that are available in cities, or attach them to fire extinguishers. So when basically the amount of data that you want to send over is typically very small. Most of the time the data that you want to send over is not even doesn't have the real-time requirement, but potentially there is a very large number of these devices that are out there. So basically the communication can be done really well. The monitoring aspect, when you're building dashboards, that can be an interesting use case.
That's great. Any other?
Similarly, we're seeing some use cases in transportation. Also, like tracking like cars, where cars are going, and being able to report back. Trains, planes. I mean, you name it.
Planes.
Another tricky one is second screen kinds of applications, where you're watching a show or you're watching a sports event, and then you can interact with the kind of the system, and you can interact with other viewers as well.
Right.
We helped a film festival last year, and they were doing a quiz and trivia game before the movies, and they had real-time voting after the movies, and it's a nice alternative to basically marking or writing your vote for an audience award movie.
That's great.
When you can use your phone.
Yeah, and I noticed, so in one of the chapters in your book I really liked was the RFB protocol, the remote desktop. I think that's another very powerful way to use it, right? So in your VM you actually have a VNC server set up, or is it? Yeah, that's cool. Yeah. Well, you don't have to show
you get the kind of you get the kind of a hall of mirrors effect with the default configuration, because
right.
VNC server is the same VM where you have the browser, and you get the infinite recursive window.
Right. But still really
but it's
cool.
there.
Right.
You can easily reconfigure it to point to a different VNC server.
Right. And is that using the sort of the binary message types of WebSocket, or just
that's sending binary data over a WebSocket, and there's a JavaScript library that implements the remote frame buffer protocol.
Oh, okay.
So
there's so many great things out there. So one of the things I want to talk about a little bit is the debugging of these connections. So we have, for example, in Chrome DevTools, good ways to look under the hood and see what's happening. How do you, what is your debugging workflow for a WebSocket application?
So let me get started with that here on my machine.
Yep.
Let's bring up Chrome DevTools.
Good idea.
And connect to websocket.org. Websocket.org is an awesome website. It has a lot of nice resources, examples, good articles. So it's a good place to get started. The Echo test is a very nice service where basically you can create a WebSocket connection, send some data to the server, and all the server does is it echoes it back to you. So it's pretty much the first test that people use if they want to do basically test what they have. So I'm going to create a connection, and when you switch over to the network tab, and we can filter by WebSocket, what we see here is the actual WebSocket connection. And we talked about WebSocket being web-friendly, which means that actually it starts its life as an HTTP connection. So interestingly, WebSocket, the connection is symmetric. So the server can send data asynchronously, and the client can send data asynchronously. So it's bidirectional, but the way it gets created, that is asymmetric in the sense that it's always the client that has to initiate the connection. So basically the browser says, or the client, the WebSocket client says that, hey, I want to create a connection, and then do you speak WebSocket? And the server responds, yes, I do speak WebSocket, and that's when the HTTP connection breaks down, and the new connection, the WebSocket connection, takes over.
And we can see that handshake here, the request and response, with all the headers.
Right. So
maybe make it a little bit bigger.
Here we go.
There you go.
So here is the upgrade header that is sent, and here in the response is the upgrade header too.
Right. Cool.
Okay, and so once we have the connection established,
then you have the messaging that goes back and forth. Right?
Exactly.
Right.
So what you can do here on websocket.org is you can send a message, and that we see the message was sent and the response was sent back, which is the same message. So let's click on the connection again, and here we can inspect the frames. Here the background color indicates whether it was an upstream or a downstream.
Oh, okay.
You can see the length of the message, and you can see the time as well. So if you're sending a new message, you would need to click on the connection again to refresh the actual frames in here. So another thing that we could do here is, let me bring up the console. And from the console itself, we do have a WebSocket connection variable here. So here you can see the actual connected WebSockets. You see the endpoint here. And we can do WebSocket.send. And here we can say something like, hi there. And when you do this, what happens is the message is sent from the console, not from the application. So actually, I did say hi there again. I should have said something else. But basically, thank you.
Excuse me.
Here we go. So from the application, we don't log the outgoing message. We only get back the incoming message, simply because the message was not sent from the app; it was sent from the console. So it kind of gives you an idea how you can use Chrome to kind of visualize WebSocket, which, by the way, is quite a challenge because it's all kind of under the covers, and it's very handy, and it's there. You don't have to install or get anything. It's just there at your fingertips right away.
What are some of the other tools you might be using for the analysis, right?
Do we want to look at net internals maybe first?
Sure.
So if that's
So where are you going? Chrome. Okay.
Yeah, Chrome has some even more under the hood tools for inspecting the network stack. So even if a WebSocket doesn't connect, and maybe you have a DNS stall out or some other connection issue before you get that far, you can look in net internals, excuse me. But I think where you're going is, what if that's not enough?
Right.
In the case where you have a WebSocket client in your browser and a WebSocket server that speaks the protocol and everything is working fine, this is almost always enough information. You can see your handshake, you can see the payload of WebSocket messages flying back and forth. If you're writing a new WebSocket server and you need to make sure that the syntax of the WebSocket messages is correct, you might go for network level tracing, where Wireshark is an incredibly powerful tool.
Okay. Show us that.
Let's take a look at that.
The power.
So I'll just refresh websocket.org again and bring up Wireshark. Okay.
So Wireshark,
And
you can just download that for free?
Yeah,
Or-
open source application.
Okay.
We'll start a capture on the wireless device here and filter for port 80, where web traffic will be found. All right. And we'll start this WebSocket connection and send a few messages. And over here, we should see the complete bytes of both sides of the network session, including framing and masking, which are below the level of where the JavaScript application would have visibility or care about.
Yeah, so you could never get that from within the browser.
Right.
Yeah.
And it looks like with later versions of Wireshark, it'll actually dissect the WebSocket message and show you the fields in the WebSocket message header.
Okay. Well, that's great. So basically, for anything that, like your regular JavaScript applications that are, let's say, working, you can get it from Chrome DevTools.
Yeah.
If you're building things more advanced, like a server, then you might go to the Wireshark layer.
Yeah, if you're doing a new implementation of the protocol, Wireshark can be very handy.
Right. Okay.
Yeah, and we walk through using Chrome DevTools, NetInternals, and Wireshark in the book as well.
In the final appendix, right? Or
And
one of the appendixes.
We do write a WebSocket server in Chapter 3.
Exactly.
So there is an occasion where you might want to do this kind of debugging.
Exactly. Yeah.
That's great. All right. So before we jump into the questions on the moderator, so Vanessa, you're a doc manager. You've written tons of documentation. How did you find this writing an actual book different from writing docs?
Well, first it was, we're writing about a technology, a standard, rather than a product. And that was definitely a shift in just the process. And then thinking about how the best way to explain something that people will be approaching in a number of different ways and not having any sort of predictability there. So it was a really good process. It was a really intense process. But so
having written the book on the side, I'm sure you're happy that it's done. Great. Well, let's take a look at a couple of questions on the moderator. So if you have any questions on the YouTube live stream, there are links to ask and vote for more questions. So let's go to the presentation view here. All right, so what considerations in terms of scalability should you take when deploying a WebSocket-based service? In particular, what limits do you hit easier due to having to keep many connections open? So that's I guess, a commonly asked question, right? Because with HTTP request, it's sort of the request response and it's done. Here you now have a whole new paradigm of, potentially thousands or millions of concurrent connections. So how do you deal with the scalability of that? This is from Vlad from London.
Yeah.
Sure.
So maybe I'll start and then others can chime in.
Sure.
So one of the challenges that we've been facing in the pre-WebSocket world is that as we move to the web, we started using the web in a way that we expected kind of the client-server world to work. So just because we moved to the web and just because the web was not designed for the richness and the interactivity that we had in the client-server world, that doesn't mean that customers and people basically gave up on that need or on that demand. So we came up with a number of these very creative ways of introducing interactivity, and we were using HTTP, a very scalable and stateless protocol for something that it was not designed for. And by using something that was specifically designed for this use case, I think we can write our applications in a way more efficient manner. Very often I get the question whether HTTP gets replaced by WebSocket or what this whole coexistence story is. And basically, HTTP is there for all the document-oriented resources, things like images and HTML files and CSS and JavaScript. And WebSocket can be used for where it's really good, where you need to have this permanent connection for the bidirectional communication. On the scalability side, yes, it is can be a challenge simply because when you get started with WebSocket, basically you can build amazing things.
Right.
And as you start rolling it out to the web, you can face thousands, tens of thousands, hundreds of thousands of users, and suddenly things can break down. How you do clustering, how you do failover, how you do disaster recovery, all these kinds of questions come up. We did a benchmark not too long ago, and in that benchmark we had 1 million concurrent connected users served by one server. And
the server rack, right?
It was a rack, exactly. We had 10 messages sent per second to these 1 million users. The message size was 512 bytes. The protocol overhead was another 100 or 200 bytes. And we did not have a single dropped connection, and the overhead that we added on top of the actual physical network overhead that the WebSocket stack added on top of that the average was, I think, 3.5 milliseconds. So it can scale, but if you want to scale to a very large number of users, then you have to have those capabilities in the server that you are using.
Yeah, that makes sense.
Actually, that brings up an interesting point. One of the things that we talk about in the book is enabling your server to speak WebSocket.
Right.
So that would be your browser or your client talking to WebSocket to a WebSocket server, versus using a server in between that translates WebSocket traffic into TCP through the back end. And those are two different options that we go through in the book.
Cool. Very good.
So speaking of the book, and I don't know whether that would fit into any of the questions, maybe it would.
Buy it.
Sorry?
Buy the book.
There are a couple of very, very neat examples that I think we built for the book. So maybe we can show some of them. We have some here in the VM, and maybe we can walk through what that whole experience is, just so basically show how easy it is to get started. So the first one is chapter 3.
Right, so in chapter 3 we go through building a WebSocket server from scratch using Node.js on the server side. And that's really nice that we get to keep the same language for these examples on the client and on the server. So we write the server, and we have a couple of fun little things you can do with it. The basic, just echoing messages back and forth, and also a WebSocket REPL. So we have a read eval print loop that you run on the server side that executes JavaScript remotely on all of the connected clients. So I'll just start that up here. And I'll go to the chapter 3 directory and run start REPL server.sh, which is just executing Node and this WebSocket REPL JavaScript application. I'll open a couple of browser windows. I hope. And just open the client in each window, and we'll see here on the server a couple of connections came in. And so whatever we type here in the console is going to be executed by each of the browsers. And the result's going to be returned over WebSocket, and it's going to print out here again on the console. So just 1 + 1. Each browser ran the JavaScript expression 1 + 1.
Right.
That was delivered to it over the WebSocket. It comes back, it's 2. And so each session printed out 2. So we can do some pretty fun things with that. For instance, we can manipulate the actual pages running in each of these browsers.
Oh, wow.
Yeah.
That's great.
So here basically you're writing JavaScript commands that are sent over, executed on each of these browsers, and you are controlling the browsers remotely.
Yeah, it's a remote control application,
right.
driven by a WebSocket server.
It's pretty impressive, especially when you have a browser on the other side of the planet and you're remotely controlling it. It can have a pretty interesting effect.
Yeah, that brings up the question of security, Frank.
Security is very important.
Well, let's take another quick question from the moderator. So from Frank G in New York. So we have, what is the relationship between WebRTC and WebSocket? And we talked about this briefly before, and you had a great...
this comes up a lot because the one-sentence description of WebRTC is a real-time communication feature for browsers, and the one-sentence description of WebSocket is a real-time communication feature for browsers. So the headline is very similar.
Right.
But WebSocket has a client-server model. It's a very data-centric use case. And WebRTC is peer-to-peer with a really heavy focus on real-time media as what it's really designed for.
Right.
And
video
it supports
and audio,
peer-to-peer data with optional reliability. And so there are some overlapping use cases, but they're really on the margins of what they're designed for.
Right. Cool. Actually, speaking of security, so what type of security should big companies consider when offering a persistent connection to their backend services? Also from Frank in New York.
Well, should big companies offer connections directly to their backend services?
Well, that's a good question. Well, first of all,
let's offer connections directly to backend services.
Let's take a step back. So what are some of the WebSocket security considerations, like you talked about in the book? What does it boil down to?
So it has transport level security,
right,
much like HTTPS with WebSocket Secure, the WSS scheme over TLS.
Mm-hmm.
And it starts with an HTTP connection, so you have headers there that you can use for authentication. You can use cookies. And then if you use it as a transport layer protocol, that's basically what you get. You can have application level security on top, basically bring your own. Otherwise, it's a pipe, which can be encrypted.
Mm-hmm. Anything to
and then there are a number of additional security-related capabilities that some servers offer. So when it comes to kind of real-life deployments, then you may be interested in SSO integration, Kerberos integration, may be interested in protecting your environment. There are some ways of establishing a WebSocket connection without opening up any inbound ports on your firewall. Mm-hmm. So there's a large number of things that you can deploy and you can consider using when you want to basically offer these services to the web.
So how does once you get into this enterprise scenario, what does WebSocket offer anything specifically to go through load balancers, firewalls by itself, or like how should you consider that? That's pretty common in an enterprise scenario, right?
Right. So this is a major challenge because the plain WebSocket connection very often gets cut off by these proxies and routers and firewalls. So one typical thing that improves the penetration is when you use WebSocket Secure. When you tunnel your WebSocket connection over TLS, then it gets a lot better. But even that doesn't get you beyond 90 or 95%. So at that point, the question is whether you can afford to lose 5 or 10% of your potential users or customers, or whether you want to have a complete coverage. Mm-hmm. And again, this is something where implementations can differ. So there are various solutions. You can fall back to emulation, and if you do that, then there are ways how you can penetrate these intermediaries.
Okay, cool. All right. Take another question. So, that's basically the question I just answered. I didn't see that before. So network entities, firewalls, and proxies are not very friendly to WebSocket. What's the best way to use WebSocket for connections that traverse those entities? So I guess the answer is use WSS, the WebSocket
That's
Secure.
A good starting point, yes.
That's a great starting point.
Yeah, and I think
much
that's really
odds with an encrypted connection.
Right.
Yeah.
Right.
Basically, I mean, very much like Speedy, you probably would not want to have a WebSocket connection, just plain WebSocket connection, unless you are in a development or testing environment. In a production environment, you do want to have TLS.
Some otherwise controlled network.
Exactly.
Yeah. Cool. All right, so there's a question from Shafir in Israel. What about better tooling to debug problems in the WebSocket protocol, such as bad Unicode encoding? If the server generates WebSocket message browser doesn't like, it's almost impossible to find where the problem is. Have you run into that?
I have not run into that. can imagine the problem. So WebSocket text messages are required to be UTF-8 encoded.
Okay.
So if there's some other encoding, and ASCII will fly by because ASCII is a valid subset. So most of the time during development, you might be not encoding and get away with it on your server.
Right.
But if you have UTF-8, you have UTF-16 encoded string in your WebSocket payload, that the browser will reject that message.
But wouldn't that be like a server configuration issue in general, or is that something, because your client is going to speak, your browser is going to do the right thing, right?
Yeah, and that's a server bug.
Right.
But it seems like it could be a reasonably easy mistake to make on the server.
I see, right. And is there currently something in, for example, Chrome DevTools, what would happen if you got a message like that with...
It might just close the connection silently, or it might surface some error. So I guess the question is, can the browsers complain about that more coherently, more clearly?
I mean, would Wireshark be an answer here, or what do you think? Maybe?
Yeah, I'm not sure. Maybe.
Okay, cool. All right, another question from Shafir, again in Israel. When will we have built-in compression for WebSockets? So I think that was a proposal, right? For something to be added on top of the
yeah,
RFC?
there's a draft for compression on WebSockets. I don't know the status or direction of that, but it's under discussion.
Is there any implementation that you're aware of that has done anything with that?
I wouldn't know.
Right. Okay. All right. Is there a good, so Lena in LA asked, is there a good way to gracefully degrade the use of WebSocket in browsers that are capable versus those that are not? So so this is where it comes into like polyfills for WebSocket. So Vanessa, do you have a...
well, we do talk about that a little bit in our deployment chapter. We talk about emulation. The company that we work for, Kazing, actually does provide some libraries out of the box to help with that, and it's designed for any platform that you're using, like JavaScript, .NET, Flash. There's also other ways to do it that Peter can probably speak to.
Do you have any libraries out there? Like I think Node.js comes with like Socket.io or what?
Right. So there's a wide variety of WebSocket servers and libraries out there. Actually, in the book, we do have an appendix where we list those that were available when we had to submit the book for print, and many of them do have better or worse fallback or emulation. Again, it boils down to how important it is for you, whether you're okay with a certain percentage of your users or not, and where that threshold is for you.
Cool. So another question from Shafir, maybe for Frank. Why is the default binary type for WebSocket blob when that blob has no MIME type? Does it make it useless? Doesn't that make it useless?
That's an interesting question. So WebSocket messages don't have MIME types, but your higher level protocol can contain that information. So you could have some description of the content type in a previous message or in some framing around that blob, or some headers that you send along before reading the blob in that can tell the application what to do with that blob, whether to put it into a video or image or texture.
Right. Is that how you would typically code that up, or is that?
Yeah, I think it would be atypical to just blast blobs from the server and expect the client to know what to do with them, although I guess that's possible. Because the server and the client might both be under the same, control of the same application. The client could know what to expect the encoding of the blob to be.
Right, so let's come back to, take a step back here. The default binary type is blob, so what other types can you use, and how hard is it to set that? Can you
setting is pretty easy.
Right.
There's a property on the WebSocket object you set to the name of the type you want. The other option is you can have a typed array.
Right, okay. Cool. All right. So question from Stephen Cagle in San Francisco. Are content delivery networks able to cache sockets at all? For instance, if I send a request to retrieve some data through the socket, will a CDN be able to cache that response if appropriate? So I think that's a really good question, right? Answers?
I don't have an answer. I think we'll have to get back to him on that.
Yeah, but I mean, typically this would be like real-time data, right? So, but I guess sounds like a pretty interesting use case,
right?
Where for public messages or something could be cached. But okay, so we'll get back to you on that. WebSocket plus UDP-based functionality, asked Oswald in San Francisco. What are your thoughts?
Well, there's data channels in WebRTC,
right?
Which is a WebSocket-like API with a UDP-based protocol.
Mm-hmm. And that's part of like
WebRTC.
WebRTC, yeah, exactly. Okay.
But WebSocket doesn't support UDP.
No, WebSocket is
right. It's TCP
on top of TCP. I think once it's no longer on TCP, it wouldn't be a WebSocket.
Right. So that's pretty fundamental.
Yes.
But then, I guess the next step would then be to look to explore WebRTC and the data channels, right? So there's another question: how do WebSockets work with proxies? Brandon, Zachary. So we've just discussed that a little bit. I guess the main thing is that proxy servers typically tend to strip some of the headers off, and there's a pretty extensive diagram in the book that shows the sort of possible scenarios through that. So definitely check that out, Brandon. Stephen, again, does holding a WebSocket connection open involve holding a phone radio connection open? If so, does this have much of an effect on battery life? That's also a pretty good question.
Yeah, so actually we haven't specifically talked about mobile devices, but clearly slowly we are getting to a point where the web is accessed through more mobile devices than desktop devices, and how it affects this whole WebSocket and always on world. So there are a number of challenges with mobile. I mean, the classic ones in the HTML5 world would be screen real estate, but when it comes to communication, one is the level of connectivity that you have. Whether you can stay connected all the time, and very often when you're driving through a tunnel or you're flying, you do get disconnected. So that is one challenge. What can you do about that? And briefly, the answer to that challenge is that the WebSocket layer does not provide any reconnect capabilities, so it's a higher level that would have to provide that functionality, either a higher level protocol, or you have to do that on the application level. And to answer the question specifically on a battery life, if you have a connection open, that does affect your battery life. The amount of data that you're transferring does affect your battery life. So in an ideal world, you should be aware on the server side what kind of device you are talking to, what capabilities it has, and have and talk to that device accordingly. Let's say you have some streaming kind of application. You don't necessarily want to send 100 or 200 messages per second to a mobile device, or you can have a kind of a slowing down of the messages as time goes by. So there are a number of strategies that you can use, but it's definitely something that you need to have in mind and design your apps for.
Perfect. All right, so here's an interesting question. Fabito asks, what are the main advantages of WebSockets over Bayou? Remember Bayou, Frank?
Very vaguely remember Bayou in the distant past.
I think, as I recall, Bayou was sort of PubSub based.
PubSub Comet stack?
Right.
Well,
it's been a while. But
WebSocket is in browsers.
Right.
Standardized. I'm sure it has a number of technical advantages, but without remembering the details of Bayou, that's going to be hard to come up with.
Well, I think you hit on it pretty well. Like, WebSocket is the standard that is implemented everywhere, and not hard, as you've shown in the book, to really build some really some great applications very quickly using some of these other PubSub protocols on top of that stack.
Yeah, PubSub makes a giant difference. I mean, one point I wanted to make earlier on actually is that the WebSocket API is very easy to use, and it's very straightforward. At the same time, it's very low level as well. And using something like PubSub or something that is the right tool for the job is highly recommended. You can get your very first very easy chat app up and running, but when it comes to doing something for real, you do want to use
Right.
Some more targeted tools, and PubSub is a great way. Actually, most of the demos that we showed in the beginning use some PubSub, and in the book we are talking about Stomp specifically, and we use ActiveMQ as a message broker.
So what does Stomp stand for?
Simple or streaming text-oriented message protocol, which is a very simple protocol, despite the fact that it has the word simple in its name, right? So it is a simple protocol, and you can learn. And the demo that we give, actually it's a game that's in the VM that is a rock, paper, scissors game. So the idea is similar to what we described earlier on. So there are two players in two separate browsers, and they connect to each other through a WebSocket server. And they're publishing and subscribing to these messages, and that's how they communicate.
So another question from Frank in New York: is WebSocket a replacement for REST? Any thoughts on that?
So I would say no.
Okay. And why?
Because they're pretty much apples and oranges. REST is an architectural style, and WebSocket is a network protocol.
Right.
And you can build applications in a RESTful style on top of WebSockets.
Are there examples of that out there that you know of? Or is it?
I would imagine there are examples of that out there.
Okay, cool. So, Efren from Canary Islands in Spain. What is the best way to send binary data through a WebSocket connection? That should be pretty straightforward, right?
Yeah, you have your JavaScript object representing the binary data, and you call WebSocket.send. You do have a choice of types, but really it's the same on the network, so whatever type makes the most sense in your application on the JavaScript side.
Yeah, but I think a lot of the examples that are out there are still very much text-based.
Actually, we do have an example in the book that exercises this. When you drop the image on the browser, and it's sent back again.
Yeah, we have examples in the book of using. I think that was using a blob on maybe the file reader API to get the contents of the image, and just once you have the binary data available, just calling WebSocket.send on a built-in browser-supported WebSocket.
Yeah, and I think mainly because in the early days of WebSocket, it was a text-based protocol. So I think that.
Right, and I think some of the libraries, some of the polyfills don't support binary or don't support binary in all situations. And if you can only send text-based data, then you have to encode it in some way. But if you're using standard WebSockets, you don't have to really compromise there. You can just send a binary message.
Like a data URI or something you would have to use.
Yeah,
instead,
Base64.
Base64.
Right. Okay. So Vlad from London asked, what are the most important differences between WebSocket and Flash Socket? So we mentioned earlier that there were all these other alternatives. I guess you don't have to install a plugin.
So Flash has support for opening TCP connections with the FlashNet socket API. And it's not really anything like a WebSocket. It doesn't have an HTTP connection up front. It doesn't have any kind of framing of the data. But it does have a separate out-of-band request to enforce a security policy in a sort of a strange, non-standard way.
So in a nutshell, if you have socket connections from Flash or Java, you should seriously take a look at WebSocket, because that is the way you want to move your apps forward.
Sure.
I think one more thing on the Flash socket one is that in order for it to work, if you are behind firewalls, you have to open a port on those. With WebSocket, by default, WebSocket being on port 80 and port 443, you don't need to do that.
Right.
So that's an extra level of the web friendliness of WebSocket.
Pretty big.
That's a big one.
Right. Okay. So Don from San Diego is asking, is WebSocket a path to using Bonjour, zeroconf using HTML5? Not sure. Any thoughts on that? I'm not too familiar with that, but
yeah, those are. That's a protocol for configuring devices on a local network.
Oh, okay, yeah.
Right. And that's what Apple uses, right?
Yeah, I think that. Personally, I don't know if that would be a path to letting web applications participate with local network devices, or if that would even be desirable, generally from a security standpoint.
Yeah. Okay, well, we can come back to that. So, from Bangalore, NTRK, what is the significance of URL in WebSockets, and are they similar to HTTP URLs?
Yeah, so since a WebSocket connection starts with an HTTP request and a response, that is the URL to which the request is made. And yeah, it's an HTTP URL.
Mm-hmm. Cool. So we got a couple of other questions, and then we'll wrap it up. Maybe remind me to have the coupon for the book. So are there any hardware implementations that use WebSockets from Fabito? Any hardware-based WebSockets? Interesting.
I'm sure there are.
Okay.
So there are all these little devices out there, Arduinos and
Right.
the Pi.
Raspberry Pi.
Raspberry Pi,
right.
yeah. So we have played around with those. There's nothing that would stop these devices from speaking WebSocket.
Right.
I can't think of the top of my head.
Okay. Cool. So we have two more questions. Let's just quickly run through them. John from San Diego. Why not use Socket.io, which provides the same functions and also falls back to Flash and Ajax? I think, again, it comes back to the standard, right? Having the WebSocket standard implemented in all the browsers. Anything to add there?
Why not use Socket.io?
Yeah, why not
I
use
think
Socket.io?
There's a lot of people who use Socket.io, and
Sure.
And it suits their needs. So it's an excellent choice. In some cases, it's an open source free solution. So many people find that the right as the right tool. What we saw was we had a couple of customers and prospects who came to us. We have a commercial product that scales to larger enterprises and financial services at Kazing. And what we found was that there were certain corner cases that did not quite work with Socket.io. So they came to us and asked for some help. But Socket.io is the right tool for many people and many companies out there. Basically, Socket.io has a big role that it contributed to the success of the technology.
Right.
So there's a lot to be said about it.
Cool. Socket.io uses WebSocket. It's not exactly an either/or.
Yeah, exactly.
It's one of the polyfill libraries for communication that uses WebSocket as a
If it's available.
connection strategy.
That's the primary one. Yeah,
Okay.
I think.
Perfect.
Yeah.
All right. So if there's any other questions, we'll take a look at them, and we'll put in some comments after the show. We have to wrap it up. Two quick questions. What about any upcoming events where we can learn more? I mean, of course, people can buy the book, but where can we find you guys, and how can we get more information?
So we're doing a live appearance on Thursday in San Francisco for the San Francisco HTML5 user group. Ilya Grigorek, who wrote the foreword to our book, is going to be doing a talk on performance, which will be a really great talk. And the three of us will be presenting about the book and doing a book signing.
Perfect.
So we'll be there to answer questions and talk more about it.
Okay. And if people...
HTML5 DEF CON?
Yes.
Yeah, that's right. All right. You're going to be there?
Yeah, so we'll also be hosting a booth at the HTML5 DevConf. I think that's April 1st through 3rd.
Yeah.
And that's going to be in San Francisco also. And our colleague will be doing a panel discussion about WebSocket there.
Okay. And finally, the book, you have a coupon available. Can we, can you tell us about the coupon? 40% off?
Sure, yeah.
Okay.
We have a 40% off the ebook, I think.
Okay. So we can post it in the moderator afterwards. So. Great. Okay, so with that, I would like to thank you, Vanessa, Peter, Frank, for joining us in the studio, answering all of everyone's WebSocket questions, and congratulations on finishing the book. That's a huge accomplishment.
Thank you.
Congrats,
Thanks,
and
Peter.
for those of you online, thanks for hanging out here, and I hope to see you soon. Thank you.